Welcome to the Cognitive Cloud AI-enabled computing continuum. And I don't want to waste some time, just very quickly, the housekeeping rules. This session is being recorded and it will be published on the event platform. If you are not a speaker, please stay muted and keep off your video all the time. If you would like to say something, we have a feature of raising your hands. You will find it on the screen, and I will add you on the stage to speak up. But I also highly recommend, since we are running late, that if you have questions, please use the chat, the live discussion on this session, and put your questions there. The speakers will also come on the chat and they will reply individually to you. You will see the live discussion in the full screen mode. And if you have any technical issue, please ask question on the help desk. So next, you see the agenda. I will quickly go through the first, setting the scene. We have Maria Ciacalli, who is the Program Officer, Cloud and Software Unit, European Commission. And she will set the scene for this session, giving a talk on Cognitive Cloud AI-enabled computing continuum from cloud to edge. And let me just share the screen for Maria. And
thank you very much. Hello, everybody. Welcome to the session on Cognitive Cloud AI-enabled computing continuum. My name is Maria Ciacalli from the European Commission, Unit E2, Cloud and Software. I'm going to present to you today, as you all know, the aim of the session, next slide, please. The aim of the session is to really discuss the current call that is going to open up in a few days, and also to see what are the key challenges for the future of the research in this area. Next slide. Okay, so here is the agenda. You already have seen it. We have set up here a panel of distinguished experts to help us understand what is this area all about, and to give us some more explanations on what do we mean by cognitive cloud. So we're looking forward to their presentations and also to the discussion at the end. So for me, what I'm going to do is to just go over what has been happening all over these years on cloud research and how this topic has been evolved. As you know, the European Union has really supported the development of cloud computing in Europe with research and innovation actions since the FP7 program. You can see here all the different topics that were called all these years. What we aimed for this cloud research was to really develop novel solutions for cloud architectures, for federation of cloud infrastructures, and also for development of cloud-based solutions. What we had in mind was not to compete with the hyperscalers at the time, and not to have another centralized, let's say, cloud infrastructure. We're focusing on making Europe competitive by providing all the different generic technologies and advanced cloud technologies and mechanisms and techniques, especially for the SMEs in Europe, to really compete with the big hyperscalers, and also to provide the tools to really for them to create a federated cloud and not only a centralized cloud. And of course, based on the main issues of the interoperability, and also taking into account that those generic technologies that were developed have to have also applicability on a variety of applications. So what has been the impact so far of all this research? Your research, okay, that you have been developing all these years has been, contributing into accelerating the development and deployment of cloud computing in Europe. In particular, has created new opportunities for small and medium enterprises, and thus fostering the European, industrial capability in the cloud computing sector. Of course, also contributing to the development of an ecosystem that is going to respond in now the upcoming digitization of needs of industry and the public sector. Of course, from all these research that we have seen in all these work programs, all those years, many outcomes that came out of your research have produced really successful systems and results in the areas of multi-cloud, hybrid cloud, and also edge computing. And of course, these are the areas that are now going to support the Digital Europe program. And as Pierre mentioned this morning, the Future Cloud project cluster has produced, which is your projects, your work has produced a federated cloud reference architecture that has been used by developing the work programs of the Digital Europe program in Europe, and also for contributing this reference architecture to the initiative of Gaia-X. Okay, so next slide, please. So if you really want to find out about all these projects and all this cloud research in Europe, please visit the sites of our two coordination and support actions, okay, H Cloud and Hub for Cloud. Next slide. Okay, so what were the lessons that we learned going from H 2020 work programs to Horizon Europe? For sure is the need to accelerate the cloud adoption in Europe. And this has already been addressed in a way by the creation of the European Cloud Alliance that was already mentioned this morning. Also, we need to facilitate cloud and edge interoperability and portability, taking into account data privacy, security, and the applicable legislation in Europe. International collaboration, very important if you want to develop global standards and have cross-border application development to see where the problems and also trying to co-develop technologies with other countries, other continents. Examples of this collaboration has been very successful project results with Japan, Korea, and Brazil in the past. And then, of course, the need is that we should not work in silos. We should not only work the cloud, IoT, and edge computing and networking alone, but we really have to look at the whole continuum, okay? And for this, in the next work program of the Horizon Europe, this convergence is really addressed in a coherent EU research agenda from cloud to edge to IoT. Okay, next slide. Okay, you have already seen this from Max's presentation. There is a paradigm shift, okay, from cloud to edge to IoT. And what is needed is to bring the compute resources closer to the data. Of course, this does not mean that cloud research is done and there is nothing to do anymore, okay? I mean, cloud is very important because it has been given, the opportunity for IoT and edge computing, and especially AI technologies to really take off, okay? And of course, on the other hand, all these requirements coming from all these areas have produced the need to go to the next level of cloud development, okay, to the advanced cloud technologies. And in that, in this sense, then of course, now we can see how AI is going to help all these new developments. So what we need in the future is an AI-enabled cloud to edge continuum, which is going to be seamless, transparent, and trustworthy integration of all the different and diverse computing and data environments, okay, spanning from the whole continuum, from cloud to edge to IoT, and also from the networks. Okay, next slide. So this is just to give you an idea on how we work internally to prepare for the work programs, okay, in each framework program. So from Horizon 2020 to Horizon Europe now, the work program preparation has been done by taking, of course, our own thoughts, since we know all these programs all these years, by also listening to the independent experts and having their opinion on what are the trends and what we should do next, and also from other sources, like the Future Cloud project cluster, the roadmap from NESI, the position papers from NESI, and also from H Cloud. So all this together, they converge and they that's how we come up with this work program for Horizon Europe 21-22. Next slide. Okay, so of course everybody has agreed that, you know, for the future what we need is intelligent collaboration, self-organization, self-management, and self-healing across the heterogeneous resources across the whole continuum. And for this, all this has to be supported by AI technologies. And so then we come up and you know, with an AI-enabled continuum. Of course, all this has been also presented to us by the Future Cloud roadmap. And as I said before, all this together with other you know, opinions from other experts and initiatives and alliances, we came up with this work program on cognitive cloud. So next slide, please. You have seen already this slide. I won't go into it. You know that now currently we have two calls open for our unit. One is on open source and the other one is on cognitive cloud. So next slide, please. Okay, so then let me concentrate on the call on the current call on the cognitive cloud. So then what do we mean by cognitive cloud? Okay, what is it? Artificial intelligence is going to transform current clouds into cognitive clouds, okay? By applying AI techniques, we're going to have dynamic load balancing, optimize energy efficiency, we're going to have a balanced data traffic, and high and distributed reliable throughput from cloud to edge. So AI enablement of the whole continuum. So the cognitive cloud is going to interface with all the layers of the continuum and is going to respond and adapt it intelligently to the changes according to the application behavior and the data variability. And what this is going to have to offer is automatic deployment and mobility of and adaptability of services throughout the continuum. All these, you know, new mechanisms and new tools are going to really help the application developers have and give them a greater control of their network, computing and data infrastructures and services. So next slide, please. So what is needed in terms of technologies and in terms of new developments? What we need is a highly innovative cloud management layer that is going to make the best application of artificial intelligence techniques and models with automatic adaptation of the different computing resources from networks, computing, and storage. Seamless, transparent, and trustworthy integration of diverse computing and data environments, as I said before, spanning from core cloud to the edge and in an AI-enabled continuum, and automatic adaptation to the growing complexity of requirements that are coming from the IoT devices and so on, and taking into account the security and data privacy and also credibility of the applications. And interoperability is really, really very important. So this is in a nutshell what we have you know, addressed in the work program, the upcoming call. And the next slide, please. And now what is left from as you know, the call is going to open on the 23rd of November and closing on the 5th of April. The budget for this call is 50 million. And we expect projects in the range of from 4 to 6 million. It's a research and innovation project only. And we expect to have a technology readiness starting at TRL 2 and finishing at TRL 5 by the end of the project. For more information, you have everything in the work program. You have the link there. Okay, so then this is the call that's coming up. So what's next? If you go to the next slide, please. So now the speakers in the panel are going to provide us with further elaboration, challenges, of course, in this upcoming call that's opening in a few days, and also what are the challenges that are going to really to address in the next work program. So having said that, I think I should finish here And I will leave the floor to you, Amrita, to present, the next the panel. And the next speaker is Lutz Schubert. He's going to
Thank you. Yes, thank you, Maria. Thank you so much. I welcome Lutz. Lutz Schubert, he is from the University of Ulm, head of research, and he will, his presentation is on cognitive cloud, the challenges and opportunities ahead. Lutz, do you want me to share your slides, or is it okay for you to yourself? You do it yourself. Thank you.
Yeah, I think that answers that question. Yes. Thanks for that. I hope you can all see the slides and hear me okay. Even after 2 years under COVID, I still feel awed talking to my slides rather than to you people. So please excuse me while I do a monologue with my slides now for a few minutes. So my name is Lutz Schubert, as already introduced, and I'm here together with Keith Jeffrey, somewhere in the background, who can answer all the complex questions that I can't answer. So what I want to talk about a bit is a bit more about the background of what smart in the edge actually means and what that means for a cognitive cloud. And I've got quite a few slides, so if you interrupt me in time, that would be very nice if I'm just taking too long. So before we get started, it's always good to bear in mind where we come from and one of the specific challenges that's behind cloud computing and why edge computing is so necessary in this context. So as you all will be aware, over the recent years, we had a growing number of devices and users connected to the internet, whilst at the same time, in reality, the numbers of servers providing that has not actually grown that much. And don't know whether you can see my cursor. Let me quickly change to, sorry, there we go. And of course, that is good and bad. On the one hand, there is a very practical reason about that, and that's just energy and cost and everything. Also, due to the diversity and the scope of everything, it does not really make sense to have basically servers everywhere. But the actual, no, that doesn't work anymore. There we go. The actual need behind cloud computing and the actual capability that we originally addressed was to be able to provide these compute resources and the data and everything on demand over the web, anywhere, at any time. So cloud computing and edge computing has specifically that focus to deal with the increasing demand of users, devices, and everything, as opposed to the limited numbers of resources. I mean, all the resources, in particular, the network and so on. So as we all know, over time, data has become the biggest challenge, and data at the same time is still the oil of the industry, right? We have data now from everywhere in any size and shape, and we want to exploit that data. We need that data. We're interested in that data. That's basically all we're talking about. But the problem is data is everywhere, and our network, no matter 5G and whatever future development we'll have, is always too slow compared to the data, its size, and its complexity. So we expect things such as that it will be without problem, we can share any data and immediately change it anywhere in the world at any time without running into security concerns and so on. So that's the general challenge. And one of the big motivators for edge computing is to get the computing and the capabilities closer to the edge, closer to the data sources, so as to make sure that we can actually compute the data in time. And there is more problems than just size of the data. It's something to be very aware of the whole time, and that is that the data is structured differently by different people in different fashions. And that's not only due to the source, the sensor in the first instance, but it's also due to what you actually wanted to achieve with the data. A webcam provides pictures, but even already all webcams provide different pictures and different quality. Same as for microphones and so on, temperature sensors. All these data need to be converted, need to be interpreted, need to be known what the intention is. But data is not only source specific, it's also code specific, because no matter how you write the code, what you actually do with it, how you convert that data, how you use it, and so on, depends on how you've written the code in the first instance. It doesn't help that you enforce new standards or whatever, because first of all, you still have the freedom to do it any way you want. And second of all, a standard may also be constrained. So we need to look at it also from the point of view of what we can actually do with the data. So in addition to that, data is shaped by hardware, not only by the sensors, but already by the memory architecture of your CPU. And a good example is GPUs. Anyone who's ever programmed them will immediately see how data changes when you program GPUs. And of course, one of the big problems is data is bound to a location. And given the speed and everything of the network, this is where we need to approach it. So given not only that, but in particular, given the modern shape of the internet, of the infrastructure, of systems and devices, we know that sensors are different, devices are different, connections are different. In particular, in the edge, we have a degree of heterogeneity, flexibility, and instability, if you want, that requires that we cannot just move a code to the edge and be happy about that, no matter with IaaS or whatever. If you've ever done your home setup, in particular in IoT or whatever, you will know it's already very difficult to just integrate a very simple sensor. And anyone right now in a video conference will also know what challenges we face just adding the webcam, the microphone, and the headsets, and how often these things go wrong. And these things are not even able to host code, and my computer, all of your computers will be different. So what we need as a key capability to exploit edge computing is that we can move code, or rather logic, freely across different types of devices, and thereby find the best device for our needs, which means that we need to restructure the code, restructure the data on the fly without the delay that normally comes with it, and that is so costly in the cloud. If we instantiate a new virtual machine, this can take minutes to hours, and if we want the flexibility of availability, then this just takes too long. So some of the key messages that need to come across in exploiting the future cloud and edge environment is, first of all, that data and code will be and have to be distributed and heterogeneous at that. Everything could potentially run anywhere in any shape and format, and that needs to be supported by the environment. That means we need to have a lot of intelligence added to that, and I'll come to that in a bit. I'll just want to motivate the overall context a bit more. So that this kind of adaptation, migration, maintenance, and so on can be supported. So let me just give you a few guiding example scenarios. I'll try to be brief about them to get a better feeling for what that kind of integration actually looks like and what kind of challenges are posed by that. So the very first example is something that you'll all be very familiar with it, right? You work together on a collaborative project, all your people are working somewhere over the world, you have your shared document and workspace, everyone just adds another document in their own format. And some people edit it and break all the formatting and so on. We're all very familiar with that. Now you want to write a report about that, a status report or whatever, or you just want to check what the progress is. So one of the first things that you'll do is you manually sift through all this data, trying to find what's relevant for that. And what you'd like to do is just to ask, give me all the data that's relevant for this specific topic. That's not possible. And that data will reside in a shared workspace somewhere. Could it be in America, in Europe, or wherever, whilst you're potentially even on the move. We all know that. You're in a meeting and you want to check up what latest editions have been there and to create your report. And then you create the report, give it to an auditor, and chances are that that auditor will want to have a chat with you. And you try to provide supporting documents and give them only a limited view because there are confidential material in there. So yeah, you know, all this kind of dynamicity always at any time, have a limited view, find the documents, make them available no matter where you are and what you're doing at the moment. Another scenario, and well, basically a very up-to-date scenario is we had a very odd millennium so far, right? It's basically filled with disasters. There's COVID, there is all the climate catastrophe going on. We are being told by NASA that a meteor will hit Earth. We have wildfires everywhere. We had Donald Trump. So we had quite a disastrous time so far. And there are important things that we learned from that time, and that is we need to be way more responsive than we are. COVID is a good example of how a delay in responsiveness, and probably also in responsibility, how this can affect, well, the world, like sitting here now rather than meeting with each other. And in wildfires and so on, this is fairly well possible because you only look at a specific region, but we already know that in terms of that, the climate contributes to that. This overall still paints a very much more complex and overarching picture where we need to have both local processing, very, very quick local processing of potential threats, of potential disasters, and global integration and interpretation of that data in order to identify who is struck next and so on. There's nothing worse but doing the wrong prediction and, for example, sending the fire truck to the wrong location whilst the fire starts somewhere else. I'll just let me add quickly a third scenario, which is also very close to what's happening at the moment. With everyone starting to work from home, we all been there at the problem of trying to set up your local environment as basically one edge so as to meet the company requirements, which is basically yet another edge. And it was not just about moving the monitors and the keyboards to home so you have an office at home. It's also about ensuring connectivity, setting up VPN if you haven't done that, making sure that there are privacy concerns met and so on. Just for our university, I think we have set up a cloud environment about 3 or 4 times, and privacy was one of the main issues why we actually needed to reset the whole thing and approach it from completely different. And then we had connectivity issues and so on. You're probably all a bit familiar with that. And now that things start to get normal again, we also have learned that it's not necessary to be in the office besides for meetings, discussions, and so on. They still don't work in a fashion like we're doing right now. So some countries are working on, or actually providing, rental temporal shared office spaces. So you can just say you need one, and they'll find or try to find one that's available for this specific time and hosts as many people as you need to meet. And here comes the problem, you still need to set it up, right? So you either bring your own device, or hopefully that's configured, or you need to configure all the environment there, hopefully by an IT administrator and so on. So it's not offering that kind of flexibility and so on that we actually want. So what you can see from all these scenarios are absolutely technically possible. There's no technical barrier or whatever in principle there. But what all of these scenarios require is a lot of manual effort. There's a lot of writing the right dedicated platform, and that will be limited to that specific use case. Already just sitting here using swapcode, and on all of you, I'm pretty sure, will at the same time have Zoom installed, WebEx installed, Teams installed, Skype installed, and will dynamically switch between them, big blue button, everything, just because all of them are tailored for specific needs. And this is already a very simple case, right? So what we need is a lot more of intelligence, flexibility, and adaptability to meet the actual demands in these scenarios, to make them flexible and dynamic and fast. So what are some of the key challenges? And I distinguish them here. I won't go through all the details. We don't have that time, probably. I'm not sure how much time I have left so far. So basically,
5 minutes, Lutz. Sorry.
Thanks a lot. So I just run quickly through that and give you some of the key highlights. So what I want to stress specifically is that to all these challenges, there is a technical aspect and there is intelligence aspect. And the intelligence aspect in most of the cases means we don't know how to do it yet, and it poses a lot of strong research challenges. So, for example, in terms of data computing, even though in particular as IT people, we always talk about data and data processing, but that is a misconception that we need to be aware of, because what we want is information. We never want data. It's not good to have a value, a number at the end, 42, the famous number, when we don't even know what we want to do or what we want to achieve. So all processing, all computing, all data provisioning has a notion of information behind it. What do we actually want to tell? And there is no good way to come from data to information. That's completely human and accordingly limited. And that, of course, comes closely to the problem of interoperability, which we already mentioned, right? You have your own view of information and how you structure the information, how you process that. And in the worst case, everyone has completely different views. It's one of the surprising things. Classically, Willem Arnhem Quiner has already talked about how can we actually talk with each other and understand each other, even though we all have completely different views of the world. So this is the level of interactivity, of interaction, that we need to achieve. It's not just the syntax, it's the semantics behind it as well. And I don't mean that in terms of web semantics, I mean that in terms of human semantics. So since we are talking about widely dispersed, very heterogeneous environments, that means that also data is anywhere, we need to process it anywhere, we need to deal with any type of data, and that under conditions that are very highly unstable, in particular in terms of the edge. We have connectivities that change the whole time, we have devices that disappear and so on. So what needs to happen is that the execution constantly adapts to the availability, to the capability, to the specific environment conditions. And that means also that we need to decide where to process the data, which data to process, how much of the data to process, and how much to process somewhere else. So this happens constantly and needs to happen constantly. And of course, one of the big problems arising from that, and there's another session on swarm intelligence, is that this can lead to highly emergent behavior, where everything just basically becomes chaotically deciding on its own, because we have so many demands occurring at the same time and contradicting each other. Emergence can be a benefit, there is no doubt, because it can lead to solutions that you haven't thought of. But at the same time, it can be very uncontrollable and become chaotic and lead to errors. So since I'm running late as well, I'm just giving you a few pointers about what needs to be considered when building up such a new environment, such a capability of a smart edge, right? We have a lot of requirements towards an environment that so far has been realized in a very strict stack-fashioned way, where each stack is considered a completely different thing on its own, code and so on. But that's actually already a misconception itself. We have, at every stack, we have to meet the constraints of the environment that we're working on and the needs of what we aim at. And data is unfortunately one of the things that sits smack orthogonal to it. So what we need is not to just add yet another stack or put everything in a stack and then be happy about it. We need to rethink how devices are treated, how devices can interact, and make these devices and so on intelligent on their own within their limited capacities. So I have listed a series of why this is relevant and so on. That probably takes away too much time. So I have just a few very specific scientific challenges that I quickly want to run through. And that is, first of all, we need to have way more ability to handle the locality of data, of code, not only in the terms of execution, but also in the way of how we already design it and develop it. We have the adaptability on all levels. We have to have find a fashion of distributed control and see when control is going wrong. We need to be able to understand what's actually happening, and we need to be able to understand why it's happening, as well as whether it still needs the purpose. And all these are, even nowadays, very, very strong AI challenges, which need to be incorporated right into devices that are not designed for it in the first instance. So I think I'm just in time, correct me if I'm wrong. So I'll try to stop here, even though I could still go on about this for hours if you want me to. Very happy to continue.
Thank you, Lutz, so much. Of course, it was very, very interesting. And yes, unfortunately, we're running short of time. And
Okay.
I would thank you so much, Lutz. And I request everybody again, if you have questions, please use the chat. And very quickly, I would like to welcome our next speaker, Domenico Siracusa. And Domenico is the head of the Robust and Secure Distributed Computing Fondazione Bruno Kessler, the center. Please forgive me if I've not pronounced it well. Oh, the floor is yours, Domenico.
I can see infinity.
Yeah, I can see that, I guess. So can you see my screen now?
Perfect.
Thanks a lot, and thanks for the introduction. Let me also thank the program officer, Maria Zaccali, for inviting me today. Yeah, infinity again, sorry. You don't see me. Now you should see me again. Yeah, perfect. So thanks to Maria for inviting me to give this talk today and the projects that are supporting this event and this session. I would also like to thank the previous speaker because he introduced the concept so well, so I can save some time on some slides, which would be redundant at this point. But this talk is going to be about our experience, my experience and experience of my colleagues and friends of the Dissenter project. The Dissenter was an EU Korea project, which just finished at the end of September. And it was focused on giving more support to AI applications and the cloud-to-edge continuum. So the idea is to present a little bit, to discuss a little bit about the project, what we did and how we did that, and also to look into the future challenges ahead in the light of the upcoming calls, clearly. So our starting point is this transition from a pure cloud approach to a cloud-to-edge approach. And here, as I said, I don't need to go into the details because the previous speaker was really brilliantly discussing all this. The thing is, I just wanted to remark something that Maria said before, is that here, transitioning to the edge, still cloud computing, it's very relevant, because what cloud computing did was giving us the possibility to scale up and to provide applications to a massive amount of people, and being able to provide unprecedented computation capabilities for the growth of new businesses. The thing here is that the movement from cloud to the edge will give us the possibility to address some of the issues of cloud computing in terms of latency, bandwidth, as it has been said, and privacy for sure. But the point is, are we currently able to deploy things and to manage workloads and application in this continuum as we are in the cloud? And this is a key challenge, in my opinion, we have to consider. And therefore, this was one of the key questions we posed when we started this center project. Indeed, we were our initial starting point was the application developer, in this case, the AI application developer. So this guy is building an AI model. So it's something that has its own connections, and it has some, his performance indicators are related to the business logic of this application. So it's the accuracy of your AI model, the completion time, the experience of your users. But as it has been said, on the other hand, you have another guy, most of the cases, who's managing an infrastructure. And this infrastructure is heterogeneous in capacity and capabilities. So you can have, for sure, for example, GPUs, you cannot have GPUs. Some nodes can be similar, but indeed have different capabilities from others. And clearly, there can be either big servers or small PCs or Raspberry Pis, and you go ahead, going towards the edge, you can go up to microcontrollers. So it is very different. It is a very heterogeneous infrastructure, which is geographically distributed and sometimes may not be definitely reliable. So what you have is you have a gap from an AI model to a service, which is finally what we can provide very well today with cloud computing. So bridging this gap was the main objective of the Center project. So I try to now explain what we did in a few slides, and then we will go ahead with the challenges and what we did also in terms of use cases. So the first thing that we tried to understand was how can we help the application developer to prepare the AI for the deployment. So the first thing we thought about was trying to see, okay, these models that you have to deploy are usually quite large. So how about you try to optimize them, make them smaller, and then put them into a box. This box is clearly now, if we come from the cloud computing world, we're talking about Linux containers, Docker containers, but in general containers, so that we can use them as pieces which can be put together in a complex application. Indeed, once you have your AI that is put in a box, then you can use other boxes, other containers, other applications, other modules, other tools, which you can compose together with your AI in order to create some applications. So you can have your, you can have a controller, you can have, I don't know, an OCR or something much more complex that understands what's in front of a camera. Then you can have a database or a GUI, and you can change one of these boxes here and do a very different application for a different, serving a different purpose. And another thing you could do is, okay, you can take your AI and share it with someone else. And this someone else can use it in order to create its own application over its own infrastructure. So assume you have now your application and you have it ready to be deployed. Now, the thing is, the infrastructure owner knows that the closer you get to the bottom of your infrastructure, and you now see the parallelism with the game, I guess, most of us played when we were younger, or still are playing. And the thing is, what you have less and less resources the more you go to the bottom. And the thing is, you want to find the right spot for your application in a way that it serves its needs, but at the same time it doesn't consume precious resources that you have available. For sure, some of this may be still wasted, but what you want to do is to be careful with that. And this is actually what we call orchestration. And if you have the possibility to find new spaces, share resources, find a good way to do this, you can have at a certain point the possibility to deploy further applications on top of resources that maybe are not yours and are given from someone else. So these 4 steps are actually what we did in the center, and I will go a little bit more technical now, but the idea was to propose platforms and tools to create applications which were cloud native. So based on microservices which are interrelated each other and can communicate and can serve each other and can serve other applications. So cloud native, and are based on AI. So some of this microservices were processing some data, and then being able to operate these applications in what we call the cloud to edge continuum. So the focus was on supporting the development, deployment, and usability of AI over cloud to edge infrastructure. This is actually, this is taken, the figure is not mine, but the idea is, as taken from a colleague, but the idea here is that this is a part of an evolutionary process that is now taking place. So we are moving from something, let's say, the idea of having these 2 figures that are totally different from someone that maybe may have the competence of both sides, developing an AI model and operating it. Similarly to what is happening in the software world, where you have the DevOps, now there is a transition to AI Ops, where, you know, as I said, there are all the process of analyzing data, transforming, validating, building a model, but then running it. And this is a very similar, in a smaller scale, to what the center tried to do. So we were thinking about preparation of AI and delivery of AI. So starting from the top of this figure, as I say, the first thing we were trying to do was to optimize models for running, in order to run them at the edge, where resources are, as I say, constrained. And also other things you could do is to partition them. So to divide a model into 1 or more parts in a way that privacy, so the part that is elaborating some privacy sensitive data was run at the edge, where and maybe some other information you can send to the cloud, or in order to save, in order to save some bandwidth when you're transferring data, because the closer you elaborate data at the edge, the less the data you need to send to somewhere else. Then we were having these models, we were having some way to manage them, also repository for sure. And another thing we thought about is, as I said before, you may want to share this model with someone else in a way that you make sure that your data is managed in a privacy-preserving way. So we had something we called cross-border model in data management and brokerage. Then, you have this model, you need to build your application. So it's what we call the AI package, but the function was basically taking AI and bringing it to a cloud-native service. Once you have the service, this application, you just need to orchestrate it. So we go down here into our AI delivery. And one of the most important pieces here was orchestrating it. So you have applications, you have the infrastructure, how do you orchestrate it? And you deploy it in what we call this cloud to edge continuum. And clearly, what you have to do at the same time is to take data from when these applications are running, take data from sensors and devices and share them with the application by means of IoT platforms. Here we evolved some of the existing platforms in order to be able to avoid sending all the data doing the brokering in the cloud, but instead doing this brokerage directly at the edge, so on edge devices, to have a distributed brokerage. And another point that we really liked, and we did, evolving IoT platforms to provide digital twins, in the sense that we were making platforms, this IoT platforms, a knowledge basis for sharing not only data from sensors and devices, but also from AI applications. So getting the inference from some AI applications and sharing that inference with other applications that are already running in the infrastructure. So to create a knowledge that is distributed in this infrastructure. Surely, once you have all these applications deployed, you need to monitor them to see if the SLA agreed when you were deploying them is respected, and if not, you want to reorchestrate it, or if you also want to check what you can do at the level of optimization. And finally, we were doing anomaly detection over the monitored data in order to understand if there were any anomalies. In this picture, you can also see what was developed mainly in Europe and in Korea. But let me also stress an important point here, that this collaboration gave us the possibility to grow up from the technical perspective, because we found that our counterparts, our colleagues in Korea, were very much expert on AI and managing in AI and optimizing AI, while on our side, we were more knowledgeable about platforms. So this technical collaboration gave us, incredible results from our perspective. But also on the standardization, this was a great path for us, because in some bodies like ISO, IAC, that gave us the possibility to collaborate with our Korean counterparts and go together jointly and present a unified vision of an entire project. And finally, also the possibility to talk and interact with people from another continent, with industry from another continent, with different needs, because at the end of the story, and we always have to remember this when we develop technology and science, we need to cater to some needs, either the general public or the consumers or the customers, but having a quite wide perspective on this and a very wide angle, that was really important for us. So we were really grateful to have the chance to have this European-Korean collaboration. So to finalize this, key innovations here. So the first innovation was about orchestration. We were able to cater to AI application requirements while optimizing resource utilization. We used, in order to catalyze offer and demand of computing, data, AI models, we were using a blockchain-based brokerage framework. So we used the blockchain technology. It served us. It wasn't the core, but we used it. And we improved IoT platforms to provide AI, augmented knowledge base, and we had our AI preparation tools to ease the transition from models to services. Where did we use it? We had 4 use cases. You can go to our decenter-project.eu page. You go under the use cases, you can find some real, I hope you like videos that present those use cases. The first one was about smart cities. We were trying to ensure safety for pedestrians who are crossing streets in the city of Trento. So we did this with the municipality of Trento. Why we did so? Why we used this approach? Because we wanted to do this as fast as possible. The reaction has to be very quick. So the point was latency here. We use orchestration to make sure that all the components that need to give us an answer on time were located where they had to be located. And we use an IoT platform to augment all the information we had from the environment, microphones, sensors, cameras, and so on and so forth. And we achieved that. We were always able to have a very low latency below 50 milliseconds. Another use case was about robotic logistics. This comes from an SME in Europe. They are using robots to move things around factories. The point was these robots are battery powered, so and they have very limited capacity. Just with the simple applications that are needed to go around the shop floor of companies, they have the capacity, computing capacity that is remaining is very small. So what you have to do is orchestrate the workloads in the robot in a way that you ensure you can provide added value applications. And you can do also some offloading to neighbor robots. That was quite interesting to us. We were able to include some AI applications that were not possible to run before on these robots, achieving very high accuracy and at the same time reducing the CPU utilization of robots. So to manage them as a fleet of edge computing nodes, that was really what we did with this use case. Other two use cases, one was related to the construction sites, trying to safeguard workers. Here, what we focused on was sharing models, AI models across different sites of construction working across different nations. So what we were doing was using a brokerage, our brokerage platform to share models and share computing resources in a way that is privacy and confidentiality preserving. And finally, the last use case was about a smart office. When you have an office, you want to understand if you have the possibility to get in from the door, and then the panel tells you what is your agenda, what is the room you have to go. So something that makes your office smarter. Here also, you want to have a very small latency, but also you want to focus on the weight of your AI, so to be able to run it on very cheap devices. And we achieved a very high accuracy of detection of people, a high reduction of trainable parameters. So I hope you will have the time to go to the site, see our videos, and enjoy them. But these are the results of the project. I was considering, okay, what are the next steps if we think in the light of what are the challenges we see, and they are reported in the call as well, and then I will finish my talk. So from the call, the first thing I saw was, what we need really is a dynamic programming environments and tools. Here, it's an important step that sometimes is missing. So we know that application developers are developing their applications. Those applications have different needs. Sometimes they are not even explicitly said, but what is really important here is to be able to support and fill the gap between what are the needs of the application and how this application is later on deployed. This is kind of an intent problem that has to make the infrastructure more easy to program directly, starting from really the needs of those applications. While now most of the infrastructure is programmed, so the way you manage your infrastructure is based upon what are the resources you have available. The two things have to, for sure, to be put together in the same basket, but making it easier for application developers to express what they need, it's really a challenge to me.
Domenico, sorry to interrupt you. Can we please quickly, wrap up?
I have one. Yeah.
Okay,
we will finish in time.
This session by 12, and we have two more. That's why. Please wrap up quickly.
Okay,
Thank you so much. Sorry about it.
Yeah. Okay. So we're going to the edge. So we are going to the swarm. The problem is how to manage this. Ensure virtualization, programmability, and automation. We know that if we go to even smaller devices, this is not still manageable with current tools like Kubernetes and Docker. If you go to microcontrollers, it's kind of impossible. So how to manage this? And finally, security. Who can access edge resources, how you recognize threats, and how sensitive data is treated. So this is also another important part. We have done some work in the center, but there's a lot to do when you handle small devices, edge nodes, which have very small capacity. If you do security, you don't want to overburden the node to do processing of in order to ensure security and neglect core business processes. That's it. And so, as I said, intent, management of the edge, you go to the swarm, and security. That's it. I would like to thank you for the attention. And if you have any questions, just get in touch with me. Those are the handles.
Much, Domenico. Very intense, and sorry about rushing, but I have to rush the next speakers also. I sincerely apologize. The next speaker coming up is Danilo Ardania. He is the associate professor at Politecnico Milano. And Danilo, I request you to kindly keep it very crisp till 15 minutes maximum, if possible, please. I'm sorry about it, and the floor is yours now. Danilo? Somehow Danilo is, I think.
I have to refresh
Okay,
you see me now, right? Yeah,
Yes,
it's the
yes,
problem
you're
that
back.
we experienced before. And I mean,
We
so
see you.
hope
Perfect.
now you see my screen. Oh, the other screen, of course. It's
It's all right.
okay. It's okay.
Almost.
It's okay.
And
Yeah,
there.
so I mean, okay, you don't one. Okay, you see my slide now, right? Hope so. Right. So I also will try to be quick, and actually I will report the experience we have with the AI Sprint project, which has more or less the same aims as the center, but is less mature because we were funded at the last ASTI40 call, so we are at month 11. So here we have some data of AI. Here I can really speed up thanks to what was introduced by Lutz in the beginning. Actually, AI is really growing fast. We reach about, given IDC prediction, one of our partner, about 70% growth this year, even under the pandemic situation. And actually, the most of innovation really will come from the possibility of running AI application in computing continua. So this way we can really reduce the latency and improve also the security of the applications. One key point is that on one side we have this opportunity, but this heterogeneous infrastructure will bring new challenges given its heterogeneity. So, and the problem is maybe difficult because, as we know, AI is hungry, engineering hungry, since there is actually a lack of expertise, and there are also a lot of plethora of frameworks, and AI experts would like to jump from one framework to another to exploit the last thing coming in from the AI research. Unfortunately, AI design is a trial and error, is a structured process where actually even the expertise, if you are expert in image recognition, for example, it's difficult to transfer the intelligence, the experience you have in a different field. So, for example, for processing language. And as we know, deep learning is popular today because it can increase its accuracy by ingesting more data for the training. But of course, these also lead to other challenges for privacy and security. So one key point is AI also AI hungry from the cloud and the silicon perspective. And on one side, we have this opportunity to exploit the continuum, but the new challenges are also managing at best these heterogeneous resources. Here, everyone is interested in AI, given the growth, given the expected benefits. But the hardest part is not AI. Actually, if we look to the big players like Uber, Facebook, Google, actually AI code and machine learning code is just 5–10% of the full infrastructure. So actually, we really believe that here there is some need to build intelligent solution, and that given the perspective of the code, actually even AI, even if we partially cover the aim of the call with the research we do in AI Sprint, however, we really need to some intelligent management of such resources. So what we are doing in AI Sprint, we want to actually help AI developer by providing a design framework with simplified programming models in a way that one can focus on mainly in the application development, forgetting the complexity and heterogeneity of the infrastructure. We are also taking a kind of DevOps flavor because we are also providing solution for the automated deployment and dynamic reconfiguration at runtime. And we are also covering some security aspects because we have some some tasks with a focus on privacy, but we actually we allow this execution of AI application in second enclave where available, and also we provide secure boot mechanism when the trusted execution environment, for example, in the execution or in the second enclave are not available. And moreover, we are also providing some specialized building blocks with a specific focus on the AI application development. Actually, this change of this shift to edge computing, to computing continua, actually is really breaking the tradition of AI development paradigm, because so far actually most of the applications are trained in the cloud or on premises, and actually the inference happen only on one side, which traditionally were on the IoT level, if there we have enough capacity, or at the cloud level, actually, if the latency can be tolerated. Actually, with the computing continuum, however, the engineering of the model cannot be an afterthought, because what happened is that we try to develop an AI application, and then if the AI application fits, for example, in the capacity that we have at the edge, we are happy, we are lucky. Otherwise, actually, we need to reiterate on this design. So actually, really, we wanted to develop the key point of our project is to provide a solution for design for deployability. We want to have guarantee that the application that we design will have some accuracy level and will fulfill the capacity that we have at the continuum. And actually, I will be fast here. The capacity that we have at the continuum, and we want to manage also the energy, the costs, and the performance of our application. So unfortunately, the key point is, if we look at the neural networks that are used as building blocks in the most of recent applications, actually, these building blocks are not designed for the computing continuum. So what we are doing in AI Sprint, for a design time, actually, we really provide some simplified framework where, given the components of our AI pipelines, we define the candidate resources of the deployment, and given some constraints on the privacy, performance, and energy, we select the best deployment of our application. Moreover, we have also some runtime tools that actually support, given the decision of the design time, we support, in case of workload changes, the migration of the components from one computational layer to another one. We support also the changing of deployment. So what we mean is that we study the partitioning of the AI applications, and we try, to change this partitioning according to the load condition of the total of the infrastructure. And the tradition is, since we have cloud VM, of course, we scale in and out the VMs according to workload changes. Moreover, as I said, we are bringing new solutions for actually the architecture search. So actually, we're providing tools where one come with a label data set, for example, and we automatically design the neural network with a highest accuracy. But as you see here, we are adding a new dimension, which is performance. And actually, we predict the performance of AI application by relying on machine learning. So that's the most of the overlap that we have in our project with the aim of the call. And actually, so here you see that we are trading off the accuracy with the performance. And actually, here we can really prune some architecture that are not actually promising from from the accuracy perspective, and it takes also a higher time. So here we have we can identify the Pareto front, and these allow actually to speed up by from 4 to 10 times the time also for identifying the best architecture for a given design problem. And moreover, we are working also in the federated learning. We are providing solution where also not only the inference happens at the computing continuum, but also actually the training of the application. So here we have solutions for running everything in secure enclave. We have a code attestation mechanism in a way that we know that the code running is the one which is certified. So for example, we don't have some attacks because someone wanna feed some misbehavior in the model trained. And moreover, we're also doing some advanced solution where instead of sending gradients for the federated learning, we learn actually a local model of the trained data, and so we share this synthetic model instead of the data, providing privacy data running at the edge. The validation, actually, we touch 3 use cases. The first is personalized healthcare, where we want to prevent the risk of stroke, which is really relevant. The 8% of people are affected by stroke, that 80% of strokes can be predicted. So here the edge is a smartphone and the mobile phone, and actually some computation happens in the cloud. So of course here security is very important. Then one scenario which is maintenance and inspection, where we have drones going to taking pictures of for the state of the wind farms, and here the goal is actually to perform. Currently the analysis is done offline. Actually, we would like to implement application where some analysis happen while actually the drone is taking the pictures, so in real time. And finally, the last one is a farming 4.0, where actually we have a tractor that go and spray some chemicals on vineyards leaves. And here the goal, since this is done in slots today, here we would like to use intelligence actually to use the treatment, to personalize the treatment, so in a way that we just use the amount of chemical that are use of the plants. So that's all from my side. Hope I was able to save some time.
Thank you so much, Danilo. That was really very helpful. You have one question in the chat from Mark. If you can answer it very quickly in 1 minute, 2 minutes, that would be great.
Actually, we use some. We try to consider the energy consumption we want to measure. We can introduce some constraints on the energy consumption, and then we, give them some benchmark, for example, on how much is the energy at the location where the application is run. We have some driver to consider some CO2. It's not really the focus carbon dioxide emission of the focus, but it's something that we can indirectly take care. Hope this answer my question.
Thank you so much, Danilo.
You're
Mark,
welcome.
if you have more questions, please, I suggest that you
sure.
have different sessions and discussions. So please, also the speakers, they have exchanged the contact information, and I suggest to get in touch. Thank you so much. And now I invite Christina, our last speaker, Christina Aranda, co-founder of Big Onion. The floor is all yours, and please, as again, please try to wrap it up in 15 minutes. That would be really. Thank you so much. Hello. I think there was.
I'm sorry. I want to well, thank you for having me. I want to share my screen if I can. If someone
stop sharing this, I think the screen is still shared by you.
Yes.
Let's see if I can stop.
I'm going to, well, I see that someone is already sharing a screen. So
Danilo, I'm removing you from the stage quickly, but I will put you back on.
Okay.
Again.
Yes, okay, I can. Thank you very much for having me. So can you see my screen? Okay, yes. So thank you very much for me it's a pleasure to share my knowledge and experience. I founder of Big Onion, and well, my focus on this talk is pretty different of my colleagues that they are focused on intelligence process automation in all these artificial intelligence models, and also policy, and also the perspective, humanistic perspective, focus on humans, focus on citizens. As European data strategy say that I love this, the European Union leader in data-driven society. So that means that there is a lot of resources, a lot of policies, a lot of things to do about that, because the citizen has, we are watching in the talks before, we live in a connecting world. There is too many devices connecting, and we need these infrastructures. And there is one of my colleagues exposed that we need, there is engineers angry that have to manage all this data, but not all angry. We need formation, we need education. The technology is going so fast, and we need for different different strategies to increase the profiles of who works in data, who works with the cloud, who works in different technologies that's impact. So as Gardner said, that we live in a people centricity strategies, and there is a localization independence, as my colleagues mentioned before, and Maria mentions at the beginning of this session. And there is so these three keys: people, localization, and resilient delivery. With this is artificial intelligence engineering that my colleagues exposed, that we need to managing all this data, all this infrastructure, all these things. Because as we are talking during this session, the data, there is different formats, there is different origins. So we have to focus on the main data sources. We have to manage in a lot of formats, structured and unstructured data. And there is a lot of use case and application that a lot of companies, small business, they don't know to use that. So there is another challenge for the governments to show, or the governments or other companies, tech companies, show them the possibilities and capabilities of technology, cloud technology, and artificial intelligence technology. But when we talk about data, talk about technology, we talk about also risks that we have to assume, that we have to work with them. So, and we have to find a strategy. It's very important to have a strategy in 3, 5, 10, and more years, as the European Commission does, or the different national and regional governments. So, because we are in a connecting world, we are, this is a Liberian, this is a company, a Spanish company, that we are producing a lot of data. So we can manage, we have to manage this data. This is TITSA, this is the institution of the mobility institution of the government of Tenerife in the Canary Islands. So they manage the data like this. They define very good the technical architecture categories, because we talk about data, we got infrastructure, so we have to have this architecture very well done. So I don't want to stop in this slide, because my colleagues they explain better than me, and they explain very well. But it's only focus that we are producing data all the time, and we need to manage and make more efficiency all the knowledge transference, because all the data, and this is the part of that I work with, the unstructured data. 80% of the data of the companies and on public administration is unstructured data. So this is a challenge, because if we want to create, and Maria's talk about this is one of the challenges, automatize all this process. Because if we automatize this process, we can reduce the operational costs, but at the same time make more efficiency the services, the public services. Because I use as a citizen, I can use my mobile phone for doing all the transactions, all the things related with my government, my regional or national government. So we can use this artificial and natural language processing solution. This is IPA API. There's intelligence process automation that's different than robotic process automations. We talking about when we talk about intelligence process automations, we're talking about cognitive linguistic brain. There's a linguistic brain that they have, the machine that can understand all the knowledge, can automatize all the knowledge and all the documents, payments, forms, whatever you can imagine, emails. And one thing that's very important, of course, for small business, they want to get a grant or a funds from the government, is the information efficiency access through chatbots, through search engines. So we can have different people managing all this information, and the governments can automatize this and can make digital and apply. They can apply all the Agenda 2030. So, and this is the regulation, of course. We have this is the challenge, okay? We have to automatize all of this, and we have to work with cloud, with focus on the privacy, focus on this personal data, anonymize this personal data. That is a GDPR. But there is one thing that all the associations we work with artificial intelligence, as for example, Spain AI or Mujeres Tech in Spain, that we ask to the governments that there is any regulator, any office that can audit algorithms, and that they can hack these bias in these algorithms or in this data. But also there is another challenge. If we're thinking about sectors or as a health sector, if we use the technology, the cloud computing, the cognitive cloud, plus artificial intelligence solutions, anonymize the data and managing the data, we could get more impact, more services, and more and accelerate all the services that the health we can get. Okay, managing all this data connection with a Internet of Things platform, or managing all these 8 algorithms, and also preparing all this data about with different governments, with different stakeholders, but managing all this data, focus on regulation, of course, but we could do a lot of things with a social impact, because don't forget that we'll talk, we talking about economical growth, we talk about business, but we talk about social impact. The technology is a medium, but we have to focus on people and impacted contribution in positive in the sustainable development goals, because with AI, with cloud computing, with all the technologies that are related, as for example blockchain, so that we can allow transparency, we can allow more ethical use of technology. We can impact in gender equality, in partnership or goals that are going to go see, or climate action. If I choose artificial intelligence model I can analyze if I consume some energy and another. So we talk about that working in no ecosystem. We have to try to work on ecosystem, and that is that we are exposed, my colleagues, that okay, I have the knowledge and experience, but I need to share all my knowledge and experience with the rest of the stakeholders to have more impact, And as you know, Gaia in Spain, in the last call of expression of interest, there is 315 companies and 180 proposals. So that small business, startups, and big companies, they work together, and there is the very important thing. And another thing that is the sovereignty, the governance. Who is the owner of this cloud system? Who is the owner of the cloud infrastructure? From my point of view, this is a very important key thing to work, because we don't have to depend on companies, because we have to think about the people, and the people the people has ideas and innovation. And as I told you, the technology, of course, but we have to make sure the feasibility of the technology, and of course that we have to focus on these areas of the economical and growth, economic growth of the societies, of course. But the first of all is the people that who work with artificial intelligence. We don't have any ethical code, as a lawyer has, or as a medical surgery has. So we have to focus and follow some guidelines that Nuria Oliver and another experts propose, that fairness, accountability, asymmetry of data. If we train in a model, we have to focus on that, the balance of the data, transparency. This is a key thing. To explain what's happening if I use algorithm, if the article 22 of the GDPR, so it's very clear. If I use algorithm to make decision, I have to explain what's happening in this algorithm. Ethics, education. We need to make more divulgation, communication about what is artificial intelligence, what is cloud computing, the risk, but also all the capabilities of potential, and of course the diversity, because we need more diversity, knowledge, as you say. You mentioned that all this data, that is very important, all this data, structured data, all the architecture, but there is another side that I exposed to you from humanistic point of view, that as linguistics or ethical or law regulation. So in summary, we have to focus on and start with the citizen experience, user experience, people first. A lot of solutions or products, there is the end of the step. No, it has to be the first step, and make sure the connectivity and privacy. And then the second step is knowledge. We're talking about knowledge, we're talking about data, information. So we have to manage all this data, all this information from infrastructure, that we have to be owners of this infrastructure and know perfectly what's happening in this data center. And so there's linking a cybersecurity thing, cybersecurity strategies, and also is government strategies. So what the European Commission does, what the Spanish or different regional governments does. So very important to focus on this and the governance or IT, and regulation and ethics. Thank you very much.
Tina, you are on time, and in fact, we saved 1 minute. And so I just mentioned here that they want to share your contacts, coordinates, or share your slides or something, so that the participants can get back to you, since we are so much rushing, please do so here on the chat. We still have 4 minutes, and this would be helpful, so people can just one-to-one get in touch. Last, yes, speakers, please get on board, share, open your cameras. And Maria, would you like to please close the session? If you'd like to talk maybe 1 minute, 2 minutes, that would be great. We have 2-3 more minutes. Maria?
Yes, can you hear me?
Yes, yes, we hear you and we see you.
Okay.
Thank you so much.
Okay. Well, I would like to thank very much our speakers, okay, because you have provided that all the information that we really need to understand what this cognitive cloud is in terms of technological requirements, and also of the policy requirements that Christina just mentioned. I'm sure that the audience has gotten a lot of information to start thinking about, submitting proposals for this call. What I understood from you is that, yes, cognitive cloud is still the beginning, okay? So we still have lots of things and lots of research to do in the coming years. And this is very good for us because now, as you know, we're trying to come up with a next program, okay, in Horizon Europe. So then let's keep in touch, all of you and the audience as well, and try to share, your thoughts and ideas on what really should be done in the next 4 to 5 years. Okay. So once again, I want to thank you very much for coming here on this online meeting. Okay, not in person, but let's hope that next time we'll all meet in a nice place. So thanks a lot, and just see you again very soon, I hope, and let's be in contact. Thank you, and thank you, Amrita, for moderating this session.
My pleasure, Maria. My pleasure. Thank you, everybody. Thank you, all the speakers.